Now let's talk about some techniques for calculating limits. So first of all, the limit as x approaches a of a constant is equal to that constant. And the limit as x approaches a of x is equal to a. These two are fairly easy to demonstrate why that's true. If I look at the function, remember this is a function setting here. So my function y equals k, that would just be a horizontal line through the y value of k. That's what that graph looks like. So no matter what the x value is I'm looking at, the y would get close to k. Whereas this function is y equals x. So that is the line that goes through the origin with a slope of 1, and every point on here has coordinates a, right? If I plug in x is a, y would be a. So the limit would just be a. Now, if I have the limit of two functions being added or subtracted, I could take the limits individually and add or subtract the results. And the limit of two things multiplying, just multiply the limits of each. Same with division as long as g is not 0. That'll allow me to take the limit as something like 3 plus 2x. So I would break this up into the limit as x approaches 4 of 3 plus the limit as x approaches 4 of 2x. Now, we know that the limit of a constant is that constant, plus this is two things multiplying, so I can make that the limit as x approaches 4 of 2 times the limit as x approaches 4 of x. The limit of a constant is that constant. The limit of x is that number. So multiply 2 times 4, we get 8, plus 3 is 11. Notice this is equivalent to just plugging 4 in as the x in the expression. 2 times 4 is 8, plus 3 is 11. So same thing here. If I just plug in 5, 3 times 5 squared is 3 times 25, or 75, which is the same thing that I get by using the limit laws. So that tells me that for any polynomial function, I can just plug in the x as the a, and it'll evaluate the limit. So here, just plug in 4 times 2 cubed minus 6 times 2 plus 1 is 21. Same is true when I'm talking about division, as long as the bottom's not equal to 0. Same for any polynomial. Just plug in the expression. And that's a rational function. Just plug in. And then, of course, two limits are equal whenever the functions are equal for all x except at a. For any real number k, I can just plug in and evaluate the function and then raise it to the kth power. If I have the limit of some number to a functional power, just plug in to that functional power up there. And with logarithms, it comes inside the log as well. All right, let's use that to evaluate. So all of this says, basically, just plug in and try to evaluate the function. We're going to talk about what happens when you plug in and you don't get an answer that works. But I'd plug in 5 times 2 minus 1. That's the square root of 10 minus 1, or square root of 9, which is 3. Plug in 3 to the 2 squared plus 1, right? 3 to the power 2 squared plus 1 is 3 to the 4 plus 1, so 3 to the 5th, which is 243. Go ahead and plug directly in. So I would have log of 3 times 2 to the 5th plus 4. So 2 to the 5th is 32 times 3 is 96 plus 4 is 100, log of 100. So remember, this is saying the base here is 10. So what exponent do I need to raise 10 to make 100? The answer is 2. All right, now if I plug directly in here, notice what I get. 1 squared plus 2 times 1 minus 3 over 1 squared minus 3 times 1 plus 2 is 1 plus 2 minus 3, that's a 0, over over 1 minus 3 plus 2, that's a 0, 0 over 0. When I plug in and I get 0 over 0, I should be able to factor the expression and remove the common factor from the top and bottom and evaluate the equivalent expression to evaluate the limit. So I would plug in, add the 1 to this expression. I get 1 plus 3 over 1 minus 2. That's 4 over negative 1, so a negative 4. All right, now if I'm looking at the limit as x approaches 1 of the square root of 2 minus x, notice that plugging directly in would give me square root of 2 minus 1, so square root of 1, that's a 1. Graphically, we see the y values are approaching 1 when the x values are approaching 1. All right, how about the limit as x approaches 3? Now notice if I plug directly in, I get square root of 2 minus 3. That's the square root of negative 1. That's imaginary. Right? That's our imaginary unit, I. That's not on the graph. We don't see any y values over here on the graph. So this limit does not exist. We get an imaginary value. All right, how about the limit as x approaches 2? Look again, plug directly in. 2 minus 2 is square root of 0. Square root of 0 is 0. And we see as we approach 2 from the left, it's approaching 0. But what happens as we're approaching from the right? We can't approach from the right. So the limit does not exist. So notice here, plugging in doesn't work unless this is a one-sided limit. And we're going to talk about those coming up.